So now we're going to factor some trinomials where the a value is not 1. Every example that we've done up to this point, the a value has been equal to positive 1. But again, as I said, there are examples where it is not. There are examples where the a value could be 3 or 4 or 7 or negative 6.3. Okay, so there are basically 3 steps. Step 1 is you should always common factor first. So if necessary, you want to divide all 3 terms by whatever the a value happens to be. Step 2, you want to rewrite the expression so that it is a trinomial. So if either the b value or the c value is missing, you want to write that in with a 0. And step 3 rather, you want to look for 2 numbers that are going to multiply to the c value and are going to add to the b value. So we've got 2 examples here that I want to try. Again, so we're going to use each of the 3 steps. So step 1 says we're going to divide everything out by the a value. So the a value, again, this is ax squared plus bx plus c. So our a value in this particular expression is actually 2. So we're going to divide everything in this equation by 2. And we're not going to just lose the 2. We're going to carry it with us. Okay? So I'm going to divide all 3 of those things by 2. I'm going to take that 2 and I'm going to move it down because I'm not going to lose it. Okay? So 2x squared divided by 2 just leaves me with x squared. Positive 10x divided by 2 leaves me with positive 5x. And positive 12 divided by 2 leaves me with positive 6. Okay? So these 2 lines are equivalent. If I use the distributive property and I go backwards, I could do 2 times x squared, 2 times 5x, 2 times 6x, and that would take me back to that line. Okay? But that's not what I'm trying to do. I'm trying to factor the piece in the middle. So now I have a trinomial. It's right here. And I want to factor that trinomial. So in order to factor that trinomial, I need to use my MA chart. So I need 2 numbers that are going to multiply to positive 6, and they're going to add to positive 5. So if I look for numbers that multiply to 6, that's 1 and 6 multiply to 6, but they add to 7. 2 and 3 multiply to 6, and they add to positive 5. So I know that this has to be my connection here. So again, this 2 stays with me. I don't lose that. And then I've got x plus 2, x plus 3. So again, these lines are all equivalent. So this bottom line equals the line up top, which is also equal to the original line that we had. Okay, so just be aware that that's how it's going to work. The next example, again here, we actually have just 2 pieces. We're missing a b value, so let's rewrite this equation. We'll call it 3x squared. Since we're missing the b value must therefore be 0. So plus 0x minus 147. Okay, so we're going to factor out everything by the a value. And again, the a value is this positive 3. So I don't want to lose that. So I'm going to divide all 3 terms by positive 3. And I'm going to take that and move it down. So if I do 3x squared divided by 3, that leaves me with x squared. 0x divided by 3 leaves me with 0x. So I'm just going to leave it as 0x. And negative 147 divided by 3 is going to leave me with negative 49. Okay, so my next step, again, I got to carry this 3 with me because I don't lose it. I need to do an MA chart for this trinomial piece right here. So in order to do that MA chart, I have to recognize that my 2 numbers, my 2 factors, are going to multiply to negative 49. They're going to add to 0. Okay, so knowing that the b value is 0, that means that the positive version of the c value, which is 49, if I take the square root of that, that's going to give me my answer. So either negative 7 or positive 7. So negative 7 times positive 7 gives me negative 49, and negative 7 plus positive 7 will give me 0. So my factor must therefore be x minus 7, x plus 7. Okay, and so again, you have to keep that common factor out in front. So the correct answer is going to be 3 times x minus 7 times x plus 7. Okay, so let's do a couple more of examples as we go along. We've got 6 other examples that we can do. Okay, so we're going to factor each one of these things just to make sure that we're well on track. Okay, so in this case, first step is to divide everything out by the a value. So here the a value is positive 2. So I'm going to divide everything by positive 2. And I don't lose that 2. I'm going to move that out front. So 2x squared divided by 2 just leaves me with x squared. Positive 26x divided by 2 leaves me with 13x. Negative 60 divided by 2 leaves me with negative 30. Okay, so again, I've got a trinomial here in the middle. A 2 has to come down. So I'm looking for two numbers that are going to multiply to negative 30, and they're going to add to positive 13. So if I take negative 30 times positive 1, that gives me negative 29. If I do negative 15 times positive 2, that gives me negative 13. So now I'm going to flip that. So I'm going to do positive 15 times negative 2, and that gives me, whoops, positive 15 times negative 2 gives me positive 13. So my numbers have to be positive 15 and x minus 2. Okay, so my next example over here, again, I've got an a value, so I'm going to divide everything out by the a value, and the a value is 7. So I'm going to divide 7x squared by 7 and negative 33x by 7. I'm going to bring that 7 over here. So 7 is going to equal, oops. So I'm going to have x squared minus 9. Okay. I want to write that out as a trinomial, so I'm going to end up with x squared minus 0x, or plus 0x minus 9. So my b value is 0. So that means that my c value, or the square root of the positive c value, is going to be my answer. So negative 3 and positive 3. So 7 is going to be, or it's going to equal 7 times x plus 3, x minus 3. Okay. So the next example, here I've got another trinomial. Again, my a value in this case is 3. So I'm going to divide everything by 3. So that's going to leave me with x squared plus 5x plus, whoops, x squared plus 5x plus 6. So I'm looking for two numbers that are going to multiply to positive 6 and add to positive 5. And 2 and 3 happen to do that. So I'm going to end up with x plus 2 times x plus 3. Over here, I've got one a little trickier. I've got an a value that's actually a decimal, and that's okay. I can still divide by a decimal. So I'm going to divide both of these by 1 decimal 2. So, and I'm going to move that over. So it's going to equal 1 decimal 2 times x squared minus, so if I take 30 divided by 1.2, that gives me 25. Okay, so again, I have no b value. So my b value is actually 0. So when my b value is 0, then the square root of the positive c value is going to equal what I'm looking for. So in this case, it's going to equal positive 5 and negative 5. So it's going to equal 1.2 x plus 5, x minus 5. If I go down, I got my last two examples here. Here I've got negative numbers. So in this one on the left, I've got negative 2 as my a value. So it means I have to divide everything by negative 2. Okay? So if I'm dividing everything by negative 2, that means it's going to turn some things positive. So negative 2 divided by negative 2 is positive 1. So that just leaves me with x squared. Negative 6 divided by negative 2 is going to leave me with positive 3x. And positive 20 divided by negative 2 is going to leave me with negative 10. Okay? So if I go through and I fill out my MA chart, then I'm looking for two numbers that multiply to negative 10 and that add to positive 3. So 1 negative 10 gives me negative 9. 2 and negative 5, they end up being, they add to negative 3. So let's try the opposite. Negative 2, positive 5, that ends up being positive 3. So we know that this combination has to be what we're looking for. So we end up with negative 2 times x minus 2 times x plus 5. And the last example that we'll do, we've got a value of a that is actually negative 1. So when the a value is not written in there, it's actually 1. So we're going to divide everything by negative 1. So I'm going to bring that negative 1 out front. So negative 1x squared divided by negative 1 is positive x squared. Positive 5x divided by negative 1 is negative 5x. And negative 4 divided by negative 1 is positive 4. So when I go through and I'm making up my MA chart, I'm looking for two numbers that are going to multiply to positive 4 but add to negative 5. So in this instance, if I take 1 and 4, positive 1 times positive 4, they equal positive 4, but when I add them, they multiply to positive 5. So let's do the opposite. Negative 1 times negative 4 will also multiply to positive 4, but when I add them together, they equal negative 5. So this means that this combination right here is what I'm looking for. So to complete this, we've got negative 1 times x minus 1 times x minus 4. Okay, so again, when you're factoring tricky trinomials where the a value is not positive 1, again, first thing you want to do is divide all three terms by the a value. Then you want to go through and use your MA chart, much as we've done over the entirety of the last 3 days, last 3 lessons.